so if you've got your design document draft, the first draft, make sure that it's in this pile by at the end. Otherwise, again, it is due Friday by 5 p.m. If you did not bring a copy with you, make sure that you bring a copy up to the main CSE office, because you do get points for doing the drafts, right? It's not a huge number of points for just doing the drafts, but we're not grading you on how good these drafts are. It's an opportunity to get feedback on these drafts so that you can perfect it. And just like the web grader, right? You have a program, you turn it into the web grader, it doesn't work, you go back to the drawing board, you fix it, you debug it, you clean it up, you submit it again. You can do the same thing with your drafts throughout the entire semester. We're giving you 4 or 5 opportunities to submit and resubmit the drafts, but if you don't, then you don't get the feedback and you don't perfect it. Yeah, way back there. CSE office is on the 2nd floor, Avery. Let's see, csE.unl.edu. Don't worry. Yeah, there we go. It's just redirecting here. 256 Avery Hall. So if you need an actual number, it's 256. But otherwise, it's 2nd floor all the way at this end. Right? Okay. All right. So we left off last week because we have, of course, the technical writing special guest lecture on Tuesday. We left off with this airport demo, and I left a bunch of to-dos in here to remind myself that we still need to fix this stuff. One thing that I did offline here was I made a conversion to radians, right? Radians is just simply degrees divided by 180 times pi, and you're converting 0 to 360 degrees to 0 to 2 pi, right? And I made a function to do that for me. Then I used that function here to convert each one of these latitudes and longitudes into radians, so that it would work with this spherical law of cosines formula here, right? And so now it actually works and it's functional, right? That is the air distance in kilometers from the Lincoln Airport up to the Omaha Airport, which seems about reasonable, right? It's about 84 kilometers up to Epley from Lincoln Municipal Airport. So I'm somewhat convinced that this is correct, but I've also got a bunch of other to-dos here. So let me go ahead and take off this to-do, because of course I did it, right? Once you've done something, go ahead and take off that to-do. One thing I had to do here, though, was I had to use that spherical law of cosines formula along with what is this thing right here? Do you remember? I won't tell you at first. What is, maybe there's a code review here and somebody inserted a comment. What the heck is 6371? Radius of the Earth in kilometers? Okay, great. You have a better memory than I do, right? I don't know what it is. If I come back in a month from now, whoa, what the heck is all this stuff, right? 6371, what do we call those again? Those are magic numbers. They just come out of the air, right? What is 6371? If you now 6 months from now, are you going to be able to tell me that? No, probably not. So what's a better way? Let's refactor this. That is, we're going to change the code. We're not changing the functionality. It's still going to compute 84 kilometers from Lincoln to Omaha, and et cetera, but it's not going to use this magic number anymore. What should I do with that number? Here's another magic number, except for it has a clear label and a clearly understood and universal meaning. Pi is pi. Everybody knows what pi is. 3.14159, blah, 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 right? But I don't know what 6371 is. That's not universal, right? Especially if we unfortunate Americans are still on the English system. So we might not know, oh, that's kilometers right there, right? So what's a better way of handling that? Define it as a variable, maybe. All right, so what I'm going to do is I'm going to hoist this up to the class here, and I'll have a public double, Earth radius. Right? And I'll set it equal to, what was it, 6371. Right? There we go. And I'm going to take that and replace this magic number with that Earth's radius. All right? Great. Yeah. We'll get to that here in a second. So that's my first attempt, right? Now, at least in my code here, I've got, okay, great, it's Earth radius now, right? So some things that I need to additionally take care of here. First of all, who owns this variable? Well, public double, it's kind of like the airport owning its own name or its own GPS ID. It is a member variable, right? It belongs to every instance of airport demo. Now, I never create any airport demos or instances of airport demos, but you could imagine that I would, right? What if I put it over here as public double Earth radius? Now, every airport that I create has an instance of this variable and has it set to 6371. So, yeah, I've got a label for my variable, but now if I've got 50 airports, I've got 50 variables, right? That doesn't sound like an ideal solution. So what I'm going to do is I'm going to make it also static. Right? How does that change the scenario? There's only now one variable called Earth radius. And you can see that my IDE here, Eclipse, is actually highlighting that fact by making this now italicized. Right? Now, down here, it's not going to make any difference, but you should, try to follow best practices. Airport demo dot, right? For static members, for static variables, for static functions, methods, you generally use the class name dot and then whatever you're trying to access, just like math.py or math.square root, right? So that's my first improvement. My next improvement was what? You pointed out that this is actually this is a variable. It can vary, right? What if somewhere else I reset it? Earth's radius is now 0.0001, right? No. What should I do instead? Make it final. The final keyword in, oops, I need to put it over here. Final. There we go. So now it's public static final double, right? We've got many different modifiers here. But now what final means is that it's going to be a constant. It's no longer a variable, right? It's a variable in that it holds a value, 6371, but you can't change it anymore now, right? If I change it to try to be, let's go down here. If I change this to be 0.0001, right? Now the Earth is very, very tiny. Whatever the Schwarzschild radius is, right? Now I've collapsed it down into a singularity. Oh no. Right? Well, now it's not going to let me do that because I've made it final. It's no longer a variable. It's now a constant. By the way, take context clues here. What about pi? What do you think? What kind of variable is that? It's italicized. It's static, and hopefully it's final. Should you be able to change the value of pi to just 3? No. Right? Now, one thing to notice here is that when we were covering encapsulation, over here in airport, I made everything private. I made it private because I wanted to control changes to each object. I wanted to make it immutable so that all changes have to go through getters and setters. Right? Do I have that issue here? Do I need to worry about changes? So I should make this private instead and use a getter? I don't need to worry about changes anymore. Why? Because it's final. I have a guarantee that nobody can change this, just like nobody can change pi on me. There's only one variable. It's no longer really a variable anymore. It's still technically a variable, but it's constant. You can't change it. Right? So that looks much better now. Right? And a style guide here. How did I name my variable here? All caps with an underscore between names. That is the usual way of doing it, just like pi is all caps. If you have a static variable, or even if it's a constant or whatever, generally you use all uppercase underscore casing. Right? That's the typical style. Okay. All right, this looks pretty good so far. Except now, let's see. I took care of that to-do, so I got rid of that to-do already. Let's look at the rest of our to-dos. Let me go ahead and go with this one first. To-do, documentation. Do you see any documentation here at all? No. Do you see any documentation over here in airport? No, except for that to-do, but implement this, and I'll do that later or something. Right? To-do, fix this. Right? Oh, it looks like I already took care of that, but I'll come back to that in a second. So all we were looking for on your first assignment as far as documentation goes was at least an authorship header. Right? Now, in your project, you don't need authorship headers because you'll have a README file. Hopefully, you're started structuring your project already. Now, generally, in a real project, you do have like a copyright notice over every single one. Nobody's going in there and typing that. Nobody's going in there copy pasting that entire time. You have some tool that generates those for you, that has a copyright notice, and then if you need to change that copyright notice and put it under a different license or something, then you auto-generate that and put it throughout the code, right? So we don't need an authorship header anymore. That's what the README file is for. However, in Java, two things that do need to be generally documented. One is all classes. Right? All classes should be documented. This class models an airport. Airport. Lowercase a, because now I'm talking about the concept of an airport, not the class airport. Right? That's good enough, as long as you spell it correctly. Right? For more information on GPS IDs, see, and then I can put in a link here. I don't know, does anybody know a link to the FAA or GPS IDs or something like that? I can put something in here. FAA list of GPS IDs. Airworthiness directive? I have no idea. I don't know where I got my data from to begin with, but I'll just put in, I'll put in a to-do here. http://todo.com. There we go. See the FAA's website, right? Whatever. Right? And again, if I'm using doc-style comments here and I hover over it, you can see that this is well-formatted HTML. Right? You can put in a basic HTML stuff here if you want to emphasize something. You can go ahead and put, like, I don't know, code, a code tag, an emphasis tag, so italicization. Right? There we go. You can do all sorts of things. Anything that, not everything that you can do in HTML you can do here, but you can do quite a bit of stuff here. So one thing that has to be documented is every single class. Another thing that has to be documented is non-trivial methods. This is a non-trivial method because it is taking one airport and another airport and doing some complex spherical law of cosines air distance formula here. That needs to be documented. There are lots of ways of given two locations in the globe to compute the air distance between them. There's a Heaviside function or something like that. There's the spherical law of cosines. There's some Mercator projection kind of thing where you can project it down into 2D, and then you can use a regular old Euclidean distance and stuff like that. So we need to document those details. To do that, again, I'm going to use doc-style comments. Doc-style comments start with a /**, and then have a nice aligned vertical stars. And you can see the difference here in your IDE too, because it's all blue, right? So this function, or this method, computes the air distance between the given airport and this airport. Right? And of course, we're not using the keyword this, but it's the concept of this object. Using the spherical law of cosines. Right. For more information, now I should be able to pull something up on this. C href equals whatever. I don't know. I want this is complex math, right? So I want to learn all about this. Let's go ahead and go with a spherical law of cosines. There it is. No, the Wikipedia page is good enough. Right. Let's go ahead and put the Wikipedia page there. And we'll say Wikipedia. Right? Now, when I hover over this, I get some nice, a nice link that I can take, and I can even open your browser. Also, or your IDE has a browser functionality too, so you can immediately go to an external website here. Right? Very nice and very convenient. Okay. So, two things that are going to be required to be documented are every class needs documentation, and every non-trivial function or a non-trivial method needs documentation. Now, what's a trivial method? A trivial method is basically anything that I generated by that source generate code. Any constructors? No, everybody knows what a constructor is. And they can read the number of parameters here, et cetera. The getters, I can understand what a getter is, right? If you have reason to document some special behavior, for example, this is not allowed, whoa, this input is not allowed, or a name cannot be null, right? You put that into documentation if necessary. But in general, those are the two things that we're going to be looking for. If you were doing a real project, then somebody might be a real stickler. Your style guide might be a real stickler and say, okay, well, everything needs to be documented. At that point, you write a script to do it, right? And auto-generate documentation, okay? But this is some nice documentation for how this is actually working, okay? Looks like I did fix this, so that looks good for now. Right? Airport documentation, well, yeah, this needs to be documented, right? Earth radius, that's kind of self-explanatory, but you can document variables. For example, I didn't put that it was kilometers in the name. Maybe I put that into the documentation. This variable represents the Earth's radius in kilometers. There we go. Right. And now you can hover over it, and if you want to link to a picture of the Earth or something, you can do that too. Yeah. Oh, you know what? I'm curious whether or not you can embed images. Image source equals whatever. Let's find out. Nope, it's not going to let you do that. Probably for good reason. But this also needs to be documented, so let's document it. Converts degrees to radians in the usual manner, right? This is a non-trivial function or non-trivial method. So we'll go ahead and document it. Computes for this, I'm just going to copy and paste this down here, this documentation. Computes the air distance between the two given points. There we go. And of course, it's slightly different here, but there we go. Good. Actually, do we have, is this documentation correct? Let me hover over it. Let's read it. Right? This method computes the air distance between the given airport and this airport. So just focusing on lines 21 through 39 here, do you see anything about airports? No. So a lot of some of the times your documentation can get out of sync with what your code is actually doing. That's because, in this case, it's because I was doing copy pasta. Don't do copy pasta. So instead, let's go ahead and update the documentation here between the given latitude, longitude, and the destination latitude, longitude, using the spherical law of cosines. And you can align everything up. That's what happens when you automatically align there. Let me go ahead and see if, okay, oh, nope, it's still breaking on that, but whatever. Okay. That needs documentation. What about main? Do you think main needs a documentation? No, I would argue no, because it's one of those trivial functions, right? Everybody that knows, if you know Java, you know what the main is, right, and what its purpose is. It's the main entry point, okay? This one was our first attempt at computing the air distance between two airports. And we didn't like it because it broke encapsulation, right? Up here, this completely breaks encapsulation. If I have to rip out the latitude and longitude from an object and then pass it off to another function to get my result, that's breaking encapsulation. This is terrible breaking of encapsulation. But the other one is slightly less bad, but it's still bad in that I'm passing two airports off to another function. The best solution that we had last week was this, where I've got the code that acts on the data in the class where the data belongs. So you are doing all three of your encapsulation: grouping of data, the protection of that data through private member variables, and the grouping of functionality methods that act on that data. By putting it in the class, I've put it where it belongs. Okay? So should we get rid of this? I don't know. I kind of like it, right? In fact, I've got code duplication here, right? I've got conversion to radians, and I've got conversion to radians and that spherical law of cosines. So I kind of like this, and maybe I can reuse it somehow, but where does it belong? First of all, ask yourself what the functionality is. Given 4 numbers, latitude, longitudes, right? It computes the air distance between those 2 points on the sphere, on the Earth's sphere, right? Does that deal directly with airports? No. So it doesn't belong in the airport class. Does it deal with addresses? No. Does it deal with person, right? Or what else did we have for the airport? Contact or person or something like that. Or does it deal with dates? No. So where does it belong? Does it belong in the airport demo? This is just a demo file anyway, right? Ostensibly, since I called it a demo file, I'd throw it away in the end when I'm done designing and testing everything, right? So I see a lot of stuff here that is kind of related. Distances, like air distance, degrees to radians in order to do that, the Earth's radius, right? I'm seeing a lot of stuff that deals with distances. Maybe it belongs somewhere. Maybe it belongs in its own class, even though it's all static. I'll call it distance utils. Utils short for utilities, right? Kind of, that sounds familiar. What? Maybe not in the name, but what if I had a use for a bunch of math functions? Where would you put them all? In the math library, right? So you have not math utils. There is another math utility class for other different types of maths. But math, right? You could call this distance instead. I'm going to call it distance utils. It's a bunch of utility functions here, right? Now it's no longer airport demo. What is it? Distance utils. Oops. And I can convert all of those over. There we go. That seems a lot better. You put stuff where it belongs. It belongs in a class with a name that describes a collection of stuff, right? And over here in airport demo, I can get, oh no, sorry, there it's airport demo. I can get rid of all that stuff. Now I've only got my main, which sounds like it's exactly what you want in a demonstration file anyway. Right? So I've taken care of documentation. I've done this to a degree. Let's explore that a little bit more as we go along here. But one thing I want to take care of is let's refactor that references. Okay, so what I'm referring to there is that. Right, I'm comparing the distance from this airport, the instance of the airport, to that airport. I only called it that for illustration purposes. Right. So that we would understand that there are 2 objects here, this object and that object, and we were from the perspective of this object. What's a better name here? Should I call it O'Hare? It's not always going to be O'Hare. I shouldn't call it a particular one. So what's a generic name for an airport? Airport, right? Now it might look odd that you have 2 airport. Right? But it's not, because one of them is uppercase. You followed good naming conventions. All of your classes are all upper camel-cased. All of your variables are going to be lower camel-cased. Following a good style, a good consistent style, an accepted style means that you'll understand the differences between these 2 when you see airport. Right? Another acceptable name might be just A. Right? But I'll go ahead and leave it as airport. Actually, wait a second. So that, now I have to change it. I have to change this one. I have to change this one. Okay. I don't want to type that much. Here's yet another IDE trick if I haven't showed it to you already. Highlight a variable, right-click, refactor, rename, airport, and they're all renamed for you. In fact, what else is renamed? Up here in your doc style comments, it was able to recognize that this airport, the name of this variable, was tied to this variable right here, and so it changed it for you automatically. Right? What we saw in homework 1 was a lot of people documenting the minimum of authorship, but using non-doc style comments. Start adopting doc style comments. It's in every language now. Right? There are CPP docs for C or C++. There are PHP docs for PHP. It all follows the same thing. It's almost universal. The one disappointing thing that I found is that Python doesn't actually do this. Python has their own way of writing documentation. I forget what it is, but that was kind of disappointing that they don't have these doc-style comments here. Right? But anyway, now that's changed. Right? Now, of course, it's not compiling because of degrees to radians. Okay, well, that's over in the distance utils now, right? Distance utils. All right, I'll go ahead and change all of those as well. Change, change, change. Right? And also, likewise, distance utils dot Earth's radius. Make sure I make that change. Right? And I converted it to all radians, right? So it looks good now. Except that, wait a second, this looks really familiar here. Over here in distance utils, there's some distance utils. There we go. Over here in this, do you see any difference here between this and what I have over here in my airport class? No. Your eyes do not deceive you. Here's another IDE trick. If you actually want to take two classes and compare them to each other, highlight them over here, airport and distance utils. I've highlighted them both. On Mac, it's just hold down command, and in Windows, I think it's hold down. It's multiple select, hold down control. This works in web pages. This works everywhere. This is a universal graphical user interface thing. Right click and compare with each other. So of course, there's going to be a lot of differences here, but look at this. Is there any difference between my two functions here, other than the parameters? Other than the parameters? Nope. So I've got a lot of code duplication. Right? How could I get rid of this code duplication? Call that utility function. Right? Call distance utils dot. Here we go. Return distance utils dot get. Oops. Dot. Oh, what? Oh, did I not make it static? Did I screw up? Oh, sorry. Static. There we go. And back to the airport. Dot get distance utils. Now I do need to rip out the latitude and longitude, except I'm in the class. So I'm not ripping it out of the class anymore. I'm already there. I'm just taking it off the shelf. So the latitude of A is going to be this dot latitude, this dot longitude, this dot, or not this, but airport dot latitude, and finally airport dot longitude. And you can't see it, but I will bring it up. There we go. There. Nice, really ideal solution now. If I ignore everything else, ignore address here for a second, everything in here now has to do with airports. Yeah, it's got an address, but it's composed of other objects. That's fine. Over here in distance utils, there's no mention of airports anywhere here at all. Right? If I made a class called homes, right, and the homes had addresses as well as a latitude, longitude, location on Google Maps, I could reuse all of this code. And it's because there's no references to airports here that it's more universal, it's more generic, it's more general. Right? All right, great. And then, of course, maybe this belongs somewhere else. You could argue that degrees to radians, that doesn't really have anything to do with distances. Maybe we have my math utils class that I'm going to put that into or something. Right? But it's good enough for now. Okay. Did I get rid of all my to-dos in here? Well, not this one. To-do, implement this. I don't want to. Is that going to break something? Nope, it doesn't break anything. This is being highlighted because it's not being used. Okay, so maybe I'll put in a to-do to come back and handle that, but that's okay. I've refactored that references. I've refactored everything to completely separate the functionality. Right? And now everything is working great together. Lincoln, I can get their address. We moved Lincoln several degrees east or west, I forget which it was, printed that out to show that that's in fact a different one because we used a copy constructor. Right? Let me go ahead and run this and make sure that I didn't break anything. Looks like it's correct. Now, one thing that the LAs did report was that some people were having trouble wrapping their heads around chained methods. We don't call them chained methods, and I didn't call them chained methods in class, but you can do that. For example, here I'm doing, here's Lincoln.getAddress. What if I just wanted the, I don't know, the street address of it? Dot, get, or city, right? Dot, 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 right? This, the same thing that we covered last semester with, if you were in the last semester, with structures. When you've got composition, a structure owns another structure, owns another structure. You start at the top. This, then dot, and then the member structure, dot, and then the next member structure. You can chain function calls too as well. So let me look at what this looks like for output here. And we're just getting, there's that line that's being printed. It's just getting that one street. Right? This is going to be a string, so you can actually call functions on it too, right? Like to lowercase or to uppercase, right? I want Lincoln all in uppercase or something, right? And I get a shouting Lincoln, right? So you can chain function calls as long as they're returning objects. The chain here is that this is an object. The getter returns another object. Right? This is a airport object here. This is an address object. That address object has other objects. It's composed of 4 strings. This gives you a different object of type string. String has a method that you can call on it, right? To uppercase, which returns another object string so that you can print it out. Right? That's chaining. Why is it called chaining? Well, like links in a chain, right? You have one link, and then you put on another link, then you put on another link, and if you've done this several times, you've got a chain there. Okay. All right. Pretty good. Any questions so far? Because we've only really started on object-oriented programming. And what I want to do now is go out of tutorial mode and start talking about what we've discussed so far, but at a higher level. Right? So overview. Okay. There's a history of OOP. Right? Now, the first programming languages were not. I'm not going to give you a whole history because it's 30, 40, 50 years, however many years you want to count, what counts as object-oriented programming. But there's a whole history here. The first programming languages were not object-oriented. The first programming languages, if you actually needed to program something, what did you do? You took a punch card and you punched it out. You were programming in binary. You were speaking machine language. Right? Now the history of computing, right? That's tedious. Right? So what we do is we design an assembly language instead. Right? We abstract it a little bit. That assembly language still is talking machine, but at least it's using English instead of zeros and ones. That was huge progress because now we can talk in terms of, okay, instead of 0111000, right, just speaking gibberish, now we can speak in concepts of take the value stored in this register A, add it to the value stored in register B, and then store the result in register C. If the result stored in register C is greater than 0, then jump to this memory location over here. Right? That's how an if condition works. So that still forces you to think like a machine. Everything I just said there was in terms of hardware. This register, that register, that register. Right? I want to think like a human. In human, we don't. In human terms, we don't think like a machine. We don't have registers, right? We have thoughts, right? But we don't speak in those terms. What terms do we speak in? If I want to talk about airports, what do? I define something, a concept of an airport. I define a class that represents an airport so that I don't have to worry about the mundane details of, okay, well, there's this string, and also this string is an array of ASCII text characters delimited by, or ended by a null terminating character. And by the way, if you need to expand it, then you need to call malloc and do all this stuff, right? You're thinking in C. You're still thinking like a machine. Object-oriented programming is a little bit higher level, right? We're still not there to where humans think, right? What level would that be? AI. Oh, okay. Oh, hopefully we don't build AI. Programming as like humans. What would be the ideal programming language for us that we're working towards, right? We started down here at machine language, and then we're working up. What? Oh wow. Okay, that's beyond this room. Thought oriented. Yes, I just think it and it does exactly what I want. At least okay. So I'm not telepathic. I'm not that evolved yet. So what do? I speak. Natural language programming. Right. Now don't use NLP. That's natural language processing, like programming stuff like Alexa and crap like that. What I'm talking about, that's basically the idea, right? We're still not there because Alexa still doesn't know what the heck you're talking about. Or I guess I've got Siri on here. But that's the ideal programming language, right? Star Trek, you just tell the computer, you don't type what you want into the computer. You tell the computer what it wants, what you want, and it interprets for you. And okay, excellent, I understand exactly what you want, right? We're still not there yet because human language, most natural languages are not as precise as a computer. There's nuances. There are idioms that that even other people in another language wouldn't understand if you translated it, right? Raining cats and dogs, right? Translated into another language, that'd be like nonsense. But in English, it sounds perfectly fine. So that's a little bit of that. That's my view of the history, that object-oriented programming is a progression of programming languages. Now you no longer are forced to think purely in machine terms. Now you can think in terms of objects, right? I've got a bank account system I need to design. Instead of thinking about numbers and characters, ASCII text characters, what I can start doing is I can start doing a bottom-up design where I think of actors and entities. There's a bank account, right? So I need to go ahead and model a bank account. There's an owner of that bank account, so I need to model an owner. And what's the relationship between them? Is it composition or is it something else? That an owner has a bank account or that a bank account has an owner? How do I model that? But now I'm thinking at much a higher abstract level here instead of being forced to think like a machine. Okay? And that's one of the advantages of object-oriented programming. It facilitates the modeling of real-world entities. Facilitates modeling, probably one L. There we go. Give myself some more room here. It lends itself, right, to modularity and decomposition. Right? Because an object, you can decompose that into other objects so that you can have a relationship between them of composition. There's a clear demarcation of responsibilities. Right? Airports shouldn't have to worry about spherical laws of cosines, right? Distance utils should have to worry about that kind of stuff. Distance utils should not have to worry about airports, right? Because it's more universal, and they have a relationship between each other, but one thing is not the other. Right? If I go over here to airport and look at it again, an airport is not an address. An airport has an address. And likewise, an address has no backwards corresponding relation to an airport. Right? An airport has an address, but an address doesn't necessarily have an airport. Everybody would have an airport in the middle of their kitchen or something. Right? It doesn't make sense. Local date, well, what is that? How is that represented? I don't know. Food for thought in a moment here. Right? Think about that. There's a clear demarcation of responsibilities. Airports should be responsible for airport stuff. Dates should be responsible for date stuff. Addresses should be responsible for address stuff. Okay. You have the concept of what are called abstract data types. Abstract data types, right? Basically, it's objects. Objects are a particular realization of ADTs. Right? Abstract data types are simply just things, like, for example, lists. What is a list? A list is a collection that holds stuff in a particular order. Right? That's an abstract data type. It's abstract because, did I say that it holds strings? Or did I say that it holds airports? No. It just holds stuff. How does it hold stuff? I don't know. I don't care. It just holds stuff. I can put stuff in. I can take stuff out. Right? I don't have to worry about those details because it's all abstracted away and taken care of by the class, by the data type itself. Right? There are many OOP languages, and many languages adopt OOP aspects. Right? For example, C++, or the first generation of object-oriented programming, when it became popularized, would of course have been C++, right? C, and then C became, well, where did C, remember where the name C came from anyway? Why did they call it C? There was a net language before it called B. It was BPCL or something like that, BCPL. I forget what it was called, but you know, it's not inventive, right? Kritigan, Ritchie, okay, well, what's the next one? We'll call it C, right? So why is it called C++? What do you go for? Int I equals 0, I is less than n, I plus plus. It's the next I. So this is the next C. And that, again, it's not very clever. Right? You also have, at the same time, Objective-C, which is all but essentially dead. What uses Objective-C? Does anybody know Objective-C or has programmed a little bit in it? It was replaced by Swift. It was really only popular on Mac OS. So if you were programming for the iPhone, say, 10 years ago when it came out, whenever that was, then you were programming in Objective-C. They switched over to Swift now, right, which is much more Java-like if you really want to call it that. But they switched over because nobody really bought into Objective-C. Right? You also have Java and C#. Right? These are kind of the second generation, if you call these first two the first generation. These are kind of the second generation of object-oriented programming languages. Now, there were object-oriented programming languages prior to that. Smalltalk is usually credited as one of the first real object-oriented programming languages where you had the concept of objects. But since then, right, PHP and JavaScript have adopted more OOP style. Right? And I put Python into that too, but except the classes were always part of Python. Python have adopted OOP style among other styles. Right? Python is descendant from a more functional programming style paradigm, but it has objects. So again, these lines get extremely blurred. Java has adopted more functional style stuff in recent years. So you can't ever really say that this object is an object-oriented programming language. Well, it's primarily an object-oriented programming language, but it also has some functional aspects to it. It also has some procedural aspects to it, et cetera. Right? Don't worry too much about the classification of programming language styles. Eventually, you'll take a programming language class like 322 and learn about these styles. Maybe you can read up on them, but it's really not that important. My concern is let's get some stuff done, right? You can get stuff done in an object-oriented programming language. You can get stuff done in a functional programming language, right? Who cares, right? And the lines get a lot. Now, I'm sure that there are programming language researchers out there that are screaming at me right now, but oh well, none of them are here. Yeah?
In terms of performance, how does OOP languages compare to other normal?
It's incomparable. I mean, you're never going to beat metal. You're never going to beat the hardware. And what's closest to the hardware? Well, I'd argue C. But then, then other people will argue, well, no, Python is just as performant. But when you look at, well, what's Python written in? The interpreter is written in C. All right. If you're calling some heavyweight function, like somebody asked on the first assignment, is GMP, which is GNU multi-precision library, because they wanted to compute the inverse using the Euclidean algorithm. Great on them. They wanted to do that in PHP. That's not written in PHP. That's a C library that gets called from PHP. Right? Even Java has what are called the Java Native Interface, JNI. If you've got some heavyweight stuff that you need to do, then you hand it off to a like compiled C. Right? So I can't say that there's a performance. The other factors dictate performance way more than the programming language paradigm. The programming language paradigms come in into play when you're talking about maintenance and readability, simplicity, and conceptually. Like, are you able to solve this problem with one line of code because that's how the programming language thinks, right? Or that's how you think about it in the programming language. Great, go ahead and do that, right? So object-oriented programming languages are great for graphical user interfaces, right? You can program graphical user interfaces in other paradigms, but then you have to bend over backwards, right? Because it's a different thought process with respect to that style, right? So performance-wise, you can't say anything. Right? So that's again, that's all the history that I want to give you. There's a whole bunch more history if you really want it, but whatever. I can give you an OOPSLA, which is Object-Oriented Programming Language Seminar. It's a conference that still goes on. The inventor of C++, I think, Bjarne Stroustrup. I don't know if it was him or somebody else, but giving a history lesson on object-oriented programming. Right? They can get really pedantic on, no, that's not object-oriented, or that's not sufficiently object-oriented for my definition. Right? You get a bunch of people arguing about artificial stuff that taxonomy. Right? You'd get a bunch of biologists arguing, well, that ferret belongs in this genus. No, that ferret belongs in this genus over here, right? And then you can argue about it and talk about it until you come to a consensus or something. That's kind of the same with programming languages, but it's way less exact because you don't have biology to fall back on. Right? All right, so formally, an object is a general concept, right? It's a general entity characterized by three things. One, identity, right? That it's an aspect of the object that distinguishes it from all other instances. Right? So identity in terms of Java would be if I create one airport for O'Hare and another airport for Lincoln, they have some way of identifying themselves, right? Under the hood, so to speak, they're just being stored in different memory locations. This is why you have to be careful with string comparisons. You can't use equals equals because these are two strings here. These are equals equals if they're stored in the same memory location. That's what equals equals does. That's not a way to give it identity. That's one way of giving it identity, but it's not a great way of giving it identity because it'll say hello and hello. No, these are not the same thing. You want a different concept of identity, and so you write a function that these two string objects are the same thing if they contain the same letters in the same order and are the same length. Right? But this is more general. Identity is more general. State, right? A collection of properties, right? Elements, attributes, data, fields. In Java, we're just going to call them member variables. Right? But some languages like to use different words for stuff. Some authors like to use different words for things. All of these would be equally acceptable. Right? And finally, behavior. Similar to object encapsulation, we've got three things, right? We've got state and behavior. Behavior is simply just the functionality of the object, or what it does, or the services it provides. Right? How can I use this object? Will it save something to a database for me? Will it log something to a file? Will it open up a file and process it and do something else? Right? What does it offer me as far as functionality? Right? Communication between objects is done via message sending. Right? And all that really comes down to is, for now, is you simply invoke a method on an object, right? And it runs the code, right? And the object determines which code to run. Right? Similar over here, right? Get air distance. I'm not actually invoking it. Technically, I'm not invoking a function when I call it get air distance over here in airport. What I'm doing is I'm sending a message to this Omaha object. Omaha, give me your air distance, and by the way, I want you to compute your air distance from this Lincoln airport, or to this Lincoln airport, it doesn't matter. Right? Then over here, airport decides, okay, given that thing, I'm going to call this function over here that exists in memory. I know where it is because I'm the object. Right? This is going to become way more important when we look at inheritance. Because with inheritance, you can have an object up here that has some functionality that refers to the method over here, method A. Then I've got two subclasses that override that method. Right? Method A is doing something completely different over here in this subclass. Method A is doing something completely different over here in this subclass. The message sending mechanism means that I don't know. I've got three functions in memory. Which one is called? I don't know. I don't care. All I do is send a message to the object, and it decides which one of these three functions to actually call. Right? Sending the message, and it takes the message, and it decides what to do. It's called dynamic dispatch. Right? You're dispatching a message, basically. Right? Communication is facilitated using the objects interface. Right? And for us, all that really means are the publicly available methods. A Java class's interface. Now, we're going to have a keyword interface later on. Don't confuse it with that. That's why I'm putting it in the quotes here. A Java class's interface is its publicly available methods. It might have private methods like private getters or private setters or something like that. Publicly? Publicly available methods. Right? And you're not allowed to get to those private methods, right? Like you're not allowed to get you to the private state for good encapsulation. Instead, you get through the only way to interact with an object is through what is publicly published. Oh, I can call that function over there, or I can call that function over there. Again, you're not really calling functions. You're sending a message, and the object is calling those functions. Okay? But it's all opaque to us, and we don't need to worry about that. Right? Another aspect is that objects are constructed instead of assigned. Right? And again, as you witnessed in your lab yesterday, and as a review of what we did in a lecture last week, tell me about constructors in Java. By default, do you have a constructor? By default, a no arg constructor is provided. All right? It assigns default null or 0 values, right, to an object's state. By default. Of course, you can override that default by explicitly defining a no argument constructor. In Java, if you define a constructor, you can define as many as you want. The default goes away, right? But you can always restore it. Right? You can define lots of different ways. You can have copy constructors. Right? You can have partial constructors. Right? Just take the name of the airport rather than the name and the GPS ID and the latitude and longitude, right? So, etc. Object design. Objects are designed. Right? A general approach is that semantics dictate design. And that's exactly the tutorial that we just went through last week and today, more last week. I asked you, what is an airport? Right? So you ask yourself, what is essential to defining an airport? And we said, well, a name. Okay, well, then I design my airport object with a name. Also, we need a location, latitude and longitude. Oh, those are two numbers. So I'll design that to have two numbers. You could also design it to have a pair of numbers if your programming language supports that. Or you could define, latitude, longitude, that's a location. Maybe I need to define another object, right? Remember what I said about that with respect to names? Don't over-engineer your objects. It would have been wrong, probably, to create a location object just for the purposes of wrapping up two numbers, latitude and longitude. Yagni, you ain't going to need it, right? If you don't reuse that location object, you probably don't need to design that location object. Just like if a person is a first name, last name, maybe middle name. All right? You don't need to define a name class to hold these three things together. Right? But semantics dictate design. You simply break you break a real world entity into smaller parts until either it is simple enough to just represent it directly, say a string, number, etc. Or what's the other stopping point? So think top-down design from, say, last semester, where you take a reasonably complex problem and you break it down into smaller and smaller subproblems until you get the smallest problem, at which point you say, okay, that's one line of code. Or, gee, that's not one line of code, that's many lines of code, but there's a library function to do it for me. Right? So you break it down until an object already exists for it. Right? That's what I did over here in the airport demonstration. I wanted an address, and so I made an address, which was 4 strings. Right? I wanted a date that it was built, and so I thought, okay, well, maybe I need a year, a month, and a day, so maybe an object. No, wait. Right. Ask yourself, is the problem already solved? Is the entity already modeled? And yeah, the program Java provides a local date object for me already. So no need to reinvent the wheel there. An object already exists for it, just use it. Okay? Or reuse it. Just reuse it. That's one of the purposes of object-oriented programming, is to facilitate code reuse. All right? Let's see. Generally, prefer composition when relating objects to each other. Right? Alternatively, inheritance, but more on that later. Probably next week. Okay? We'll talk about that later. Composition is where an object is composed of other objects, and you see that directly over here. That an airport is composed of 4 objects and 2 primitive types, 2 doubles. Right? Those that object is the stub of the object. I don't know what's inside of a string. I don't care. And that's one of the other pillars of object-oriented programming that we'll talk about here in a second. But otherwise, it's composed of an address object, and an address object is composed of string objects, et cetera, et cetera, et cetera. Okay? All right. So, however, avoid the God Antipattern. Right? So first of all, we need to define what an anti-pattern is. To do that, we need to define what a pattern is. A pattern is a piece of code, or it's a pattern of code that is reused over and over and over again. There's an entire book on this called Design Patterns, written by the Gang of 4, like creational patterns. So patterns that are used over and over and over again to do common stuff, like boilerplate kind of stuff. And so they're called patterns because they're nice reuses. They're nice habits to get into. What would be an anti-pattern? What's the opposite of a good habit? Bad habit, right? There's something they're a bad habit to get into. For example, if I have, now think last semester, just procedural programming. If I have 10, 15 different things that I'm doing, I put everything into main, right? I've got a main that is 300, 400 lines of code. What should you do with that big, giant chunk of code in C? Well, this part does something, this part does something, this part does something. Remember what we did yesterday? We looked at that big, giant mess of code. This was doing something, this was doing something. Maybe I should take this chunk of code that sorts that stuff and do what with it? Replace it with a sort call, or, failing that, take it and put it into a method, right? And then reuse that method. That's the God Antipattern, because it's a bad habit to get into. The God Antipattern with respect to object-oriented programming, a class should only know about its own stuff. It should not know everything, do everything, be everything. Because that's what God is, right? The God antipattern here is that you've got a God class. This class is omniscient. It knows everything. You stuck all your variables into one class. It does everything. You stuck all of your methods into one class. It is everything because there's only one. You did this on your first homework. Maybe some of you did write. A lot of you asked, "Can we make a game class?" Absolutely. You were thinking, "No, I don't like the God antipattern. A game is a game, and a game report is a game report." Right? Those are different things. So you immediately wanted to create an object. It's natural to do that. Right? So object-oriented programming is in a sense kind of natural. Right? Yeah.
Yeah. So where are we going this semester to look at the results we're getting for our grades?
The question about grades. That'll be announced on Piazza when it's done. The course leaders have until 5 o'clock today to do their quality checks. After that, I pull stats, I make a report, and I post that to Piazza, at which point I open it up on Canvas and on CodePost. Since this is the first one, as I said on CodePost before, if you've not used it, fine, don't worry about this. But if you have used it in the past, you'll have to use your Huskers email from now on because of a UNL policy change. We'll be sending that out soon. Right. Okay. So those are objects. And again, let's go with the 4 pillars. Right. The 4 pillars, as I listed them last time, are abstraction, encapsulation, inheritance, and polymorphism. Right? And just to review here, well, I already did encapsulation. Encapsulation is the grouping of data, the protection of data, and the grouping of functionality that acts on that data. Okay? What I want to do with our remaining 10, 15 minutes here, all right? Yeah, is talk about the first one, abstraction. So to motivate this, I'm going to ask you a question. How does math.sqrt work? I asked this question in Computer Science 1, which has nothing to do with object-oriented programming. I asked this question because, what's the right answer? Say it louder. Yeah, who cares? I don't care. Right? It computes the square root. Right? When you pull out your calculator in grade school and you see the square root button, right? You just hit it and a square root of 2 is 1.41, whatever. Right? You might have been curious, like, I wonder how that button works, right? I wonder what algorithm is underlying that thing. It could be some Babylonian interpolation method. It could be an EDSAC method. It could be any number of 100 different ways of computing the square root of a number. Right? The answer is, who cares? That's what abstraction is. You have procedural abstraction. Right? Complex computation is encapsulated inside a function. Right? You use the function. You don't need to worry about its details. Right? Procedural, it's just one E, I think. Yeah, there we go. What does that look like with respect to object-oriented programming? Let me ask you another question now. How does local date represent a date? Now, what's the real answer here? Fast forward to the real answer is, who cares? Right? It's an object. We don't have to worry about those details. All right, well, maybe we're curious about that button on our calculator. Maybe we're curious about this. What's one way that we could represent a date? 3 integers, right? A year, a day, and a month. Okay. Is there another way of representing a date? Let's see. I have to look at my notes here to get what it is. It's ISO 8601 formatted string. Right? For example, 2020 02 06. That's the date. Then the time is going to be 12:04. Now 15 seconds. That was 1 second ago. And then 0.0000, and then Greenwich Mean Time. Well, we're not in Greenwich Mean Time. We're in Central Daylight Time, CDT. Daylight savings is on right now. No, it's not. It's off. Central Standard Time or Central Daylight Time. Right? I don't remember if it's on or off right now. But something like this. Right? That's another way of representing a date. Is there another way of representing a date? A single number. Right? For example, the Unix epoch. What time is it right now? Does anybody know? Unix time. There, that's the time right now. Or it was when I did my Google search. There's the time. In fact, here's the Unix time. Hopefully it has a running time counter. There we go. There's the time right now. And okay, if I hit update here, then there's the time now. There's the time now. There's the time now. Do you see how it's working? It's a single number that's counting the number of seconds from January 1st, 1970. That's the Unix epoch. After that, we have positive numbers. Before that, we have negative numbers. One drawback to that, of course, is that eventually you'll have overflow in a couple of billion years, as long as you're using a 64-bit integer. You'll have overflow in, I want to say, less than 20 years. Unix epoch deadline. I think it's 2032, isn't it? 2032? No, it's 38. There we go. The year 2038 problem. That if you're using a 32-bit signed integer, then that's when you run out of digits, and it goes back to whatever 68 years before 1970 was, so 1902 or something like that, right? Because you'll then have overflow. Right? Again, what is the real answer here? How does the local date represent a date? Who cares? Right? So the point of abstraction, you don't need to worry about how an object is represented internally, right? Only how to use it. Right? I've got an airport object. I don't need to know that it has a name and a GPS ID and a latitude and longitude, right? To illustrate that, come over here and look at this last line of code in the airport demo. In fact, just look at this one line right here. Right? Do you need to know anything about those airports at all at that point? How they're represented? No. I've got an airport, Omaha, and I've got an airport, Lincoln. I do need to know that there's this function out there called get air distance, so that that's the interface. That's the publicly available interface. I don't need to know that then it rips open the internals, pulls out those two numbers, hands those two numbers off to a different class, uses the spherical law of cosines or whatever. Right? All those details, I don't have to worry about it. All I have to do is call this one method. Right? The internals, both the implementation and the representation, are completely internal to the class. I don't have to worry about it. The answer is, again, who cares? Right? How does an airport work? How is an airport represented? Who cares? Unless you have to write the class. At that point, you care. Right? Another example is how does the Java's string class work? Again, what's the answer? Who cares? You just know that you've got this string and this other string, and you want to put them together. Plus, right? That's concatenation. I don't have to worry about all that. Think now back to C. Is it that simple in C? No, you have to worry, how is a string implemented in C? Now the question is no longer who cares. Now the question is, I care very much because I want to avoid buffer overflows and segmentation faults and all the other lower level details that we have to care about in C. Right? How do you concatenate two strings in C? strcat, except for I want to concatenate this string to the end of this string. What do I have to do? I have to make sure that there's enough room, right? I have to do my own bookkeeping, right? Also, what else do I have to do at the end of the string if the functions don't take care of it for me? Null terminate it, right? I have to worry about memory. I have to worry about all these details. That's procedural style. But now, over here in Java, to concatenate two strings together, do you have to worry about any of those details? No. Who cares? Right? I'm just getting the job done now. Right? So from that perspective, object-oriented programming languages are way more convenient. You have to write a lot less to get a lot more done. Right? Now, whether or not, just like, Star Trek, right? Instead of writing an entire 1,000 line program, if I just had a one sentence order to a computer, right, and it understood what I did, that's the ideal, right? We're not there yet, but we're way closer than we were in the 50s, where we have to do punch cards and program in zeros and ones, right? So much better, right? Object-oriented at least. Right? All right, questions so far? Again, that is abstraction and encapsulation. The two basic things that's all that's necessary for phase one next Friday. We are not expecting inheritance at all yet. If you want to look ahead and so that you're not programming yourself into a corner and start using inheritance, great. We're going to cover that next week, though. For your first phase of this project, the one covered by your design document right here, you simply need to design your objects, make sure that they have good encapsulation and abstraction to a point. They could just be data containers at this point. Once you've got that, then you need to have the other two components, that you're reading from a bunch of CSV files and building your objects over here. Once you've built your objects, you are serializing them to XML or JSON, or, for bonus, both. Right? And again, as I put in the write-up, what do you do to... I've got my object here. I need to serialize it to XML or serialize it to JSON. What should you do? Start writing code, right? Get the where was it? Get the address, then get the city, then to upper, and then surround that with an XML tag like address or city, right? There we go. And concatenate this. Is this the right way of doing something? There. Now I've got an XML tag for the city. Repeat for the address. Repeat for this. Repeat for this. All that boilerplate stuff. Or is there a better way? Use a library. Right? The one that we suggest is Xstream. It'll take care of both, I think. So the way to go about it is to use a library so that you're not writing hours and hours of code, debugging hours and hours of code. Instead, you're still spending time. You're still spending several hours, but instead of spending it coding, you're spending it reading documentation. RTM, read the manual. How do I do this in Xstream? How do I do that in Xstream? Right? And hopefully you can Google for most of that. Right? But use a library so that you're not writing too much code on your own, because code that you write on your own then has to be debugged on your own. Whereas, go ahead and cross your fingers. Hopefully the library is bug-free. Right? It's never the case, but 99.999% certainty there's not going to be bugs in a public library like that. All right.